Gravitation. What are the effects of a force acting on an object? When a force acts on an object, it can change the speed of the object. It can also change the direction of motion of the object. And in addition to this, a force can change shape and size of the object. So these are the three effects a force can bring about in an object. Which type of forces are familiar to you? We know that gravitational force, it acts between the earth and all objects near the earth. There is electric force in which the like charges, that is positive or negative charges, repel each other, and unlike charges, that is one positive and other negative charge, attracts each other. We also know the magnetic forces in which north and south pole repel, whereas north pole and south pole attract each other. Again, like poles repel, unlike poles attract. Then there is muscular force of human beings and animals. Then there is mechanical force. So many examples of forces are there. What do you know about gravitational force? We know that earth attracts every object towards itself. If you throw an object in the upward direction, it will come down because the earth will attract that object towards itself. So we have seen in the previous standard that gravitational force is a universal force, and it acts not only between two objects on the earth, but between any two objects in the universe. Let us now learn how this force was discovered. As we have learnt, the phenomenon of the gravitation was discovered by Sir Isaac Newton. As the story goes, he discovered the force by seeing an apple fall from a tree on the ground. And he wondered why all apples fall vertically downward direction and not at an angle to the vertical. Means we never see that an atom has gone in horizontal direction like this, or an apple has gone in such, means a direction which is making an angle with the vertical. We always see that apples, they are falling down. And this observation led Newton to think about the force which is attracting all these apples, and for that matter any other object which is falling on the surface of earth. After much thought, he came to the conclusion that earth must be attracting apple towards itself, and this attractive force must be directed towards the center of the earth. The direction from the apple on the tree to the center of the earth is a vertical direction at that position of the apple, and thus apple falls vertically downwards. So he thought that every object is attracted towards center of the earth. Just as shown in figure 1.1, an apple tree is shown. Obviously it is not up to the scale. A force on an apple on the tree is toward the center of the earth, that is along the perpendicular from the position of the apple to the surface of the earth. Figure also shows the gravitational force between the earth and the moon. Then Newton started thinking, if earth is attracting an apple towards itself and all other objects toward the center of the earth, this force might also be acting on the moon, as moon revolves around the earth. Newton thought that if the force of gravitation acts on apples on the tree at different heights from surface of earth, can it also act on objects at even greater heights, much farther away from the earth, like for example on the moon? Can it act on even farther object like the other planets and the sun So the thought process went like this. Force and motion. We have seen that a force is necessary to change the speed as well as direction of the motion of an object. We have learned the formula F is equal to m into A, where F is the force acting on that object, m is the mass of the object, and A is the acceleration of the object. We have also seen that this acceleration A is v minus u upon t, where v is the final velocity, u is the initial velocity, and t is the time taken. That means there is acceleration if there is a change in velocity of an object. And whenever there is an acceleration, there is a force acting on the object. So we can say that when the velocity of an object changes, it must be because of the force applied on that object. And this is Newton's second law of motion. Newton gave 3 laws of motion. The first law states what happens in absence of a force. He said that if no force is acting on an object, then the state of motion of the object will not change. That means if the object is stationary, it will remain stationary, and if the object is traveling in a straight line with a constant speed, it will continue to travel along the same direction with the same speed. Second law gives the definition of the force. He said that the rate of change of momentum of an object is directly proportional to the applied force, and the change in momentum occurs in the direction of applied force. The same formula F is equal to ma is actually derived from Newton's second law of motion. And Newton's third law is action-reaction law. It says that for every action there is an equal and opposite reaction acting simultaneously. That means he said that force can never be applied in a singular manner. Force always acts in a pair. For every action force, there is an equal and opposite reaction force which acts on the other objects. So these are the 3 laws of motion, and they define and describe force. Now circular motion and the force involved in circular motion. So tie one stone to an end of a string. Then take the other end in your hand and rotate the string as the stone moves along the circular orbit. Now when the stone is moving in a circular path, you are always pulling that stone towards yourself. You are applying force with the help of the string on the stone. And if you see that this force is changing the direction of the stone at every point, as long as we are holding the string, we are pulling the stone towards us. That is, we are pulling the stone towards the center of the circle and are applying a force towards it. The force stops acting if we release the string. What will happen if we release the string or if the string breaks due to the tension? Then the stone will move in a tangential direction. What do you mean by tangential direction? Tangent is a line which touches the circle in a single point, and that tangent is always perpendicular to the radius at the point of contact. So your force toward the center, that means the hand is pulling the string in this direction. If this force ceases to act, stops, then what will happen? Then the stone will move in this tangential direction. So from that we come to the conclusion that for keeping the stone in circular motion, we must apply a force on it, and the direction of the force will be towards center of the circular path. Thus a force acts on an object moving along a circle as it is directed towards center of the circle. That's why we call this force as centripetal force. Centripetal means central seeking, the force which is acting in the direction towards the center of the circular path. You know that moon, which is a natural satellite of the earth, also goes round in a definite orbit. The direction of the motion of the moon continuously changes during its motion. So there must be some force constantly acting on the moon which is responsible for changing the direction of its motion. As we have seen, whenever the direction of motion changes, there is a change in velocity. And whenever there is a change in velocity, there is an acceleration. And acceleration is always caused by a force. So there must be a force acting on the moon which is continuously changing its direction. And that force should be acting towards the center of the earth. So Newton thought it might be the same force that is forcing the apple to fall down. Similarly, earth also revolves around the sun. So a similar kind of force must be present between earth and sun, or all other planets and sun. From the above activity, examples and questions, it is clear that moon to go around earth, there must be a force which is exerted on the moon, and this force must be exerted by the earth, which attracts the moon towards itself. Similarly, sun must be applying the force on the planets, including the earth, towards itself, because all the planets, including earth, revolve around the sun. So this is the basic fundamental thing that came into Newton's mind while he was thinking about the gravitational force.